If you want to train your brain, the best way is to study breakdowns of how things work. Over the next 122 years, I'll walk you through the operating principles behind all kinds of structures. Today, I'll take you through a front-load washer in one go, from detergent storage, water intake, and water level sensing, to the heating element, the inner and outer drum structure, tumbling action, the drain pump, and high-speed spin drying, and then the full principles of spring suspension, damping, shock absorption, and counterweights. After this, you'll get it. What's really impressive about a washing machine isn't just that it spins the drum. It's that it can keep a load of water-soaked clothes, always pulling to one side, under control. During high-speed spinning at over 1,000 RPM, instead of shaking the whole machine all over the place. Many people think a washer removes stains by itself, but that's not quite accurate. What actually breaks down grease and grime is the detergent. What the washing machine really does is replace human hands in rubbing, rinsing, agitating, and wringing things out. So a washing machine isn't a machine that directly destroys stains. It's a system that lets water, detergent, and clothes fully interact, then uses mechanical action to carry the dirt away. First, let's look at why detergent can remove dirt. A lot of stubborn stains on clothes, especially oily ones, can't dissolve directly in water because oil and water don't mix, so plain water can't easily lift it off the fibers. Detergent molecules are designed to solve exactly this problem. One end likes water and stays in the water, while the other end likes oil and grabs onto grease. When you wash clothes, the oil-loving end burrows into the stain, while the water-loving end stays in the water. As the clothes tumble and the water keeps flushing through, the grease gets pulled off the fibers little by little, then wrapped up in water and carried away. If the water is heated, grease softens more easily, and stains trapped between fibers are easier for the detergent to reach. That's why hot water washing usually improves cleaning results. But detergent only makes stains easier to leave the clothes. What really keeps them repeatedly exposed to water flow and repeatedly rinsed away is the washer's mechanical structure. Top-load impeller washers and front-load drum washers clean in different ways. An impeller washer has an impeller at the bottom that rotates back and forth, driving the water and clothes to keep moving. The clothes rub against each other, while water and detergent keep passing through the fibers, carrying the dirt away. Its action is more direct, and the washing force is stronger, but the clothes also collide with each other more. A front-load washer works differently. It doesn't rely on a bottom impeller to stir the clothes, but instead rotates the inner drum horizontally. As the drum turns, the drum wall lifts the clothes upward, and then gravity makes them fall back into the water. So the clothes are constantly lifted and dropped, tumbling over and over, while water and detergent keep passing through the fibers. That's the tumbling wash action of a front-load washer. It may look gentler, but in essence it's still simulating the rubbing and turning motion of washing clothes by hand, except hands scrub items one by one, while a front-load washer keeps the whole load tumbling so the water can flow through on its own. Inside a front-load washer, there's actually more than one drum. The one you can see and put clothes into is the inner drum, and it rotates. There are lots of small holes in the drum wall so water can flow in and out. Outside it is an outer tub, which usually doesn't rotate. Its only job is to hold water. During washing, water first enters the outer tub, then reaches the clothes through the holes in the inner drum. So the inner drum rotates the clothes, while the outer tub keeps the water inside the machine. That's also why a front-load washer has to lock the door. Since the door is on the side, once water enters, if the door could be opened freely, the water would just pour out. Only after the door lock confirms it's shut will the machine begin taking in water and washing. So how does it know the water level is enough? It doesn't weigh the water, and it doesn't rely on someone looking at the water level. Instead, it uses a pressure sensor. After water enters the outer tub, the rising water level compresses the air in the pressure chamber, and the pressure sensor reads that change in air pressure. That lets it tell roughly where the water level is. If there's enough water, the inlet valve closes. If more is needed, it keeps filling. If you select hot water washing, the heating element under the outer tub turns on and heats the water to the set temperature. That makes it easier for the detergent to work, and grease and stubborn stains loosen more easily. After the wash cycle ends, the machine first has to drain the water. The drain pump pumps the dirty water out of the outer tub, and once most of it is gone, the drum enters the high-speed spin cycle. Spin drying doesn't use hot air to dry the clothes, but high-speed rotation to fling the water out of them. When the inner drum spins at high speed, the wet clothes are pressed against the drum wall. The water inside the clothes is forced outward by centrifugal force, passes through the small holes in the inner drum into the outer tub, and is then pumped away. The faster the spin speed, the more water gets thrown out, and the closer the clothes get to a half-dry state. It sounds simple, but here's where the real trouble starts. Clothes don't spread evenly around the drum, especially after soaking up water. A pair of jeans, a sweater, or a tangled bedsheet can all end up heavier on one side. At low drum speeds, that's not a big problem. But once high-speed spinning begins, that off-center mass turns into a huge, unbalanced force. It's like swinging a heavy object on a few ropes. The heavier it is and the faster it spins, the more obvious the pulling force on your hand becomes. It's the same inside a washing machine, except that heavy object is now a clump of water-soaked clothes, and those ropes have become the drums spinning at high speed. If that unbalanced force isn't dealt with, the entire tub assembly will shake violently, and the cabinet will shake with it. At best, the washer just gets noisier. At worst, it really can move across the floor. It may even seem to grow legs and walk away on its own. So the real challenge in a front-load washer isn't just getting the inner drum to spin. It's keeping it under control while it spins at high speed with an off-center load. The first structure involved is the suspension springs. The inner and outer tub assembly in a front-load washer isn't rigidly fixed to the cabinet. It's usually suspended from the frame at the top by springs, so when the tub assembly is hit by shock, it has some room to move. It doesn't send all the vibration straight to the outer shell at once, but springs alone aren't enough, because springs also bounce back. When the tub sways and the spring stretches, it can pull the tub back again. If there's no structure to absorb that energy, the tub's shaking can become more and more obvious. So the second component is the damper. Dampers are usually mounted below or on both sides of the tub, and their job is to absorb vibration energy. When the tub shakes, the damper gets compressed and stretched, turning part of the mechanical energy into heat and dissipating it. That way, the tub won't keep bouncing back and forth like a weight hanging on a spring. The springs hold up the tub, and the dampers dissipate the vibration. But that's not all. A drum washer also has one very simple, but very effective method: adding weight. You'll notice that drum washers are usually much heavier than pulsator washers. They're especially hard to move, and one reason is that heavy counterweights are attached to the outer tub. These counterweights are usually fixed to the top, front, or bottom of the outer tub. The purpose is to increase the mass and inertia of the entire tub system. The greater the mass, the harder it is for an off-center load to shake it around. The counterweight is like pressing a big rock onto the washing machine, so the vibration during high-speed spinning won't make the whole machine run wild. So a drum washer's vibration resistance doesn't rely on one magical part, but on a whole system working together. The springs let the tub hang and move freely. The dampers dissipate the shaking energy, and the counterweights add inertia to keep the system stable. The body frame then holds all these parts together. That's also why, before a drum washer goes into high-speed spin, it first turns a few slow rounds. It needs to spread the clothes out first and check whether the tub is obviously unbalanced. If the clothes are clumped too heavily on one side, the machine may pause and rotate again, trying to shake them loose. Only when the imbalance is controlled within an acceptable range will it slowly speed up into the real high-speed spin cycle. Otherwise, even the best springs, dampers, and counterweights can't handle unlimited force. So although a washing machine may look like it's just washing clothes, behind the scenes it's actually doing three things at once. The drum washer handles loosening fibers from the fabric. The drum repeatedly tumbles, beats, and rinses the clothes, while the drain pump and high-speed spinning remove dirty water and moisture from the clothes. And the suspension, damping, and counterweight system, which is easiest to overlook, is responsible for keeping the off-center vibration from high-speed spinning contained inside. What a washing machine really replaces isn't just human hands, but all the repetitive and tiring actions in the washing process: rubbing, rinsing, and wringing, as well as the trouble of controlling a tub full of wet clothes shaking wildly. What really makes a drum washer impressive isn't just how fast it spins, but that it can spin fast without shaking itself apart. It uses the tumbling drum to wash, uses centrifugal force to throw out the water, and then uses springs, dampers, and counterweights to suppress the off-center vibration produced during high-speed rotation. That's the core working principle of a drum washing machine.